All right, apologies to you online people. This is going to be posted much later than usual. A few of you noticed that and emailed me. Had some technical issues during first period. Now it's sixth period for me, and so I'll record this one, and of course by the time you see this it'll be posted at 2 o'clock or so again. I apologize, things are working now, so it should be back to normal the rest of the week. All right, your tests are graded. I'll return those later. They were really good, very good. So good work on those, which is good because you're going to need that information the rest of the year, especially today, but I mean all year, but especially today. Kind of peeking ahead, we tried to land things nicely for all of us on this unit. So graphing. We do have a review day. The test is going to be over 2 days because this was originally a longer test because graphing takes a little bit of time and we don't want you to be rushed. But then we realized it's not a block day next week. So we'll split the test up and kind of tell you ahead of time what's on which day, and maybe you can focus your studies, although there's really only one main topic, and that's graphing, so I'm not sure how we'll split it up. And then, because next week is not block day. And then Friday we'll have a counselor come in and talk to us about course selection for next year. And so if you're looking at that thinking, is that a free day? Yes, that is a free day. I mean, the counselor's going to come in and talk to you, but we're not doing any pre-cal that day. So this is a nice ending. I mean, obviously a test, but then Friday is an off day in terms of pre-cal leading into the week off. So that's a bonus for you and a bonus for me. Who are we kidding? So that'll work out well. All right, what I want to do next, I'm going to pass this out to you and you can fill it out. And you guys at home can make a copy of that on your own and make that little table. And in a minute I'll tell you more information about it. All right, so we're going to fill this in using unit circle values. But I want to remind you or tell you one thing, because we're going to use this to graph. And so root 2 over 2, that doesn't really help me when I'm graphing. If I type that into the calculator, it's about 0.7. So I don't want to see root 2 over 2 on here because I can't really graph that. I'd much rather see 0.7. So let's go through, and maybe one line at a time is the easiest way to go. So what's the sine of 0? And if you need a picture, you can put a picture there. So the sine would be 0. What's the cosine of 0? 1. Again, it's easy with a picture there. Tangent is equal to sine over cosine. So 0 divided by 1 is 0. At pi over 4, what's the sine of pi over 4? Root 2 over 2, but if I want to graph that, we'll change that to 0.7. Cosine's the same thing. And what's the tangent of pi over 4? 1. All right, so you finish that, and then we'll compare and talk about why in the world we're doing this. Okay, so there's our answers for, and again, this is the same information that's on the unit circle, just presented a little bit differently. So rather than looking at a unit circle, we have a table of values, which we'll use for graphing here in a minute. You can kind of sense the pattern. 0, 0.71, and then it starts going down again. 0.7, 0, negative 0.7, negative 1, and then starts to go back up again. Cosine starts at 1 and goes down till it gets to negative 1, and then starts going back up again. Tangent hops around a little bit more, which is why we're going to hold off on tangent until Wednesday or Thursday for you guys. We're focusing today on sine and cosine because that's plenty enough to focus on. So finish checking those, make sure you got the right numbers in your table, otherwise the rest of the day is going to be a mess up, kind of like if you mess up the unit circle, then it's all messed up after that. Alright, so hold that close because we are going to use that to construct the graph of sine of x. We're also going to, let me put this one on first. We're also going to do cosine of x. And wherever you do them at, most of these, this is not going to be a problem because it looks like you're all starting at the top of the page for notes. But I want us to graph sine and then cosine to be right underneath it. So in a minute, we're going to take a while to spend some time on sine, but in order to easily compare them, make sure you've got room underneath it to graph sine, or graph cosine, excuse me. Okay, so first time through on graphing a new function, like we usually just do table of values, right? You don't have to do that for some things now. You know what a parabola looks like. You don't usually make a table of values. But we don't really know what sine and cosine looks like. But we have a table of values. So at least for the first pass here, we're only going to be looking at x and sine of x. You don't really need to do that because you'll figure out what we're looking at. But there's my table of values. So I can get my scale right. What's the tallest, or what's the biggest y value we get to? 1. So I can go ahead and kind of max out my y scale at 1. This will be important later to set your scale before you set the graph. Otherwise, you're going to have a goofy looking graph. And if you just set the scale first, it would make things look a little better. What's the lowest it gets to? -1, so I can sort of bottom out my y scale at -1. And we're going to go to 2 pi, but don't put 2 pi all the way over at the right, because we're really going to go to 4 pi in a little bit. So put 2 pi halfway out there. But we got a lot of points in between 0 and 2 pi, so don't make your graph too small. Right? You guys if you stick 2 pi right there, there's no way you're going to be able to get, all the points in between there. So spread it out as wide as you can, and you'll have a better looking graph. Let's see, halfway between 0 and 2 pi would be pi. Halfway between 0 and pi would be pi over 2. Halfway between pi and 2 pi is 3 pi over 2. And you might remember that's the same order we put on the unit circle when we did it. The halves. Now we've also got fourths. I'm going to put the hash marks on there, but I'm not going to label them, only because I got enough labels on this graph. If I label the over 4s, it's going to be too crowded and I'm not going to be able to tell what's going on. So I'll put the marks on there because I have points for them, but I'm not going to label them. All right, well now I think we're ready to graph. So when x is 0, sine of x is 0. When x is pi over 4. You know what? Let's go what's going to feel like out of order, but it's how we're going to graph these in the future. So let's jump to the end. At 2 pi, we're back at 0. Does that make sense though? Think about the unit circle. 2 pi, you're all the way back around to where you started. 0 and 2 pi are coterminal. So they land at the same spot, so they have the same, you can look in your table, they have the same sine and cosine and tangent. So when we're at 0 and when we're at 2 pi, those should have the same values. Let's do the cut it in half method. So halfway in between 0 and 2 pi, we're at pi. That's another 0. Halfway in between 0 and pi is pi over 2. That's where we reach our max at 1. Halfway between pi and 2 pi is 3 pi over 2. That's where we get to -1. All the others are 0.7s. It's just a matter of whether they're positive or negative. But you can tell from the points you have probably whether they're going to be positive or negative, because this is going to, well, maybe you can't because we haven't done this graph before, but this first one's positive 0.7. Again, so a little more than half. At 3 pi over 4, we're at positive 0.7. 5 pi over 4, we're at negative 0.7. And 7 pi over 4, we're at negative 0.7. All right, let's connect the dots. Not with straight lines, though, with a nice smooth line, hopefully. It's supposed to look nice and symmetric. Mine's a little crooked over there around pi over 2, but you get the idea. If we think about the unit circle, this might make even more sense. As we rotate around the unit circle, sine is the y value, right? So it starts at 0. As we rotate around, when we get to pi over 2, we're up at 1. When we get to pi, we're down to 0. Get to 3 pi over 2, we're down to -1. And when we get to 2 pi, we're back at 0. And if we kept rotating, we would go through those same values in the same order. In fact, this pattern would repeat itself. So let's take this picture, kind of take a mental picture of that, and we're going to copy it over to 2 pi to 4 pi. So put 4 pi out there, preferably the same distance, right? You want 0 to 2 pi on your graph to be the same as 2 pi to 4 pi. Halfway in between would be 3 pi. And halfway in between those, I don't know, let's just put a mark there. I mean, we could figure it out. 2.5 pi would be the easiest way to say it, and 3.5 pi. But let's just leave it like that. So I'm going to copy this over here, because it's going to, as it rotates around, it's just going to start repeating itself. So let's see, that means at this next, let's jump to the end. At 4 pi would be back at 0. Halfway in between we'd be at 0. Halfway in between the pi's we'd be at a maximum, or at a minimum on this one. And I'm not going to put the 0.7s on there. The only point of putting the 0.7s on there the first time was to try to get you to draw a nice curved line. When you don't have the 0.7s, it's tempting, I hesitate to do this, but I don't want to see, right? I don't want to see triangles. That's not what the graph looks like. We want to see nice and smooth. But if you can do smooth curves without the 0.7s, then that's fine. And then if we kept going, it would do the same thing. So I'm just going to put an arrow out there and say, you get the idea. We could draw this forever. Let's do back up a little bit, though. Let's back up to negative pi. Again, be careful on your scale. 0 to negative pi should be the same distance as 0 to pi. Where's the graph going to be at negative pi? If we follow the pattern here, 0. What about halfway in between? Is it going to be a max or a min? Follow the curve. It's not going to bounce right there. It's going to keep going down, so there's going to be a minimum there. And again, we could keep drawing it backwards forever. So that's what the sine graph looks like. And that's going to become another parent function that you'll need to know. Now, it goes on forever, so you don't memorize the whole thing, because that would take forever. But we do want to know what one cycle looks like. And then we know that we can repeat it after that as many times as we need to. The most we'll ever ask you to do it is 2 periods. We may say, show me 2 cycles or 2 periods. Period is the same thing as a cycle. Let's see. The key points when you graph it, again, I don't need to see the 0.7s. I need to see the zeros and the max and mins. And again, if that's all you do and play connect the dots, then you're going to have a triangular looking, sawtooth looking thing. That's not what we want. But those points are enough to sort of set the graph. Another thing that's helpful to know is that our zeros are at, you tell me, where are the zeros of that graph? Where are the y values equal to 0? At the pi's. So let's say multiples of pi. If you get stuck on some of this, you can think back to the unit circle, and sometimes that'll help. As we rotate around, every time we hit a pi, we're at a y value of 0. 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, and so on. Every pi, we're at a y value of 0. So the zeros of our graph happen at the multiples of pi. And then sine starts at 0. This will make more sense when we draw cosine, and it doesn't start at 0. So that's our sine graph. We got to know that. Again, it's not going to happen automatically for you, but as you look at the calendar, today is sine and cosine graph. Tomorrow is transformation activity of sine and cosine. So you'll get more familiar with it tomorrow as well. All right, let's do cosine. Now, this is going to work best. We'll be able to make our comparisons best if your graph has the same scale for cosine as it did for sine. So if you can put it right underneath there, including the same scale, and you can look on the y values and everything between -1 and 1. So I'll kind of zoom out here to show you what I mean. Right, I got my y-axes lined up, I got 2 pi lined up, and pi lined up. And so similar graphs, one on top of the other. That way when we get through graphing cosine, we'll kind of be able to zoom out, figuratively and literally with the hover cam here, and make some comparisons. I'll zoom back in and talk about cosine. So again, with our table of values here, with this right next to us. When x is 0, what's cosine equal to? 1. Okay, and again, if you get stuck, you think about the unit circle. When the degree is 0, the x value is 1. So we're going to start at 1. So we're already different than the sine because we're starting at 1, 0, 1. Let's hop around as well. When we get around to 2 pi, again, you could think unit circle, or you could use the table that we created. What's the cosine of 2 pi? 1. And I hope that makes sense because 0 and 2 pi are coterminal, so they ought to have the same y value. If we go in the middle, the cosine of pi, you can look at your table, or you can look at the unit circle. Of course, your table came from the unit circle, so either one. The cosine of pi is -1. Some of you might be able to fill in the rest of the graph from there, but slow it down a little bit. Pi over 2, either from the table that we made or from a little unit circle there. Cosine, what's the cosine of pi over 2? 0. And same thing with 3 pi over 2, the cosine is 0. Those are the 5 key points that I need to see when it comes time for you to graph. Again, the halfway points though, for our first graph, let's put the 0.7s on there. But you can figure out where they are without even looking at anything. It's got to be between those two, so 0.7, -0.7, -0.7, and 0.7. And again, the point of doing those this time is to keep you from drawing a graph that looks like that, right? That's not the cosine graph that we want to see. I mean, it has those same mins and maxes and zeros, but should have some more curvature to it. Let's do the same thing we did with sine. So 4 pi. Let's go out to 4 pi. Halfway is 3 pi. And then 2 more halves. 2.5 pi and 3.5 pi. Let's see. At 4 pi, we should be back to cosine is equal to 1. At 3 pi, where are we going to be? A max is 0 or a min? A min will be down there at -1. And halfway in between a max and a min, we're at 0. And those are the 5 key points to graph one cycle or one period of cosine. Again, as long as you can graph it with curves rather than straight lines, you don't need to do the 0.7s. So there's 2 cycles now of cosine. Let's highlight the first one though. One cycle, one period. And then it repeats and repeats and repeats and repeats. In fact, let's sketch it backwards to -pi. So not a full cycle backwards. So that may be a little confusing. It might have been better if I'd have done the whole cycle backwards. But we peaked. So then we start turning down. At -pi though, are we going to be at 0 or at a minimum? Is your picture good enough to tell? At -pi, or you could go to unit circle. Will we be at, we won't be at a max, that wouldn't make sense. Will we be at 0 or at a minimum? A minimum. And that means halfway will be at the 0. really helps to have a good scale so that your picture makes sense. And kind of to that end, the first several worksheets, we provide the scale to help you make sure you're matching things up right. After a while, we'll take the scale off and make you provide the scale to make things work. All right, we're going to write the same things about cosine that we wrote about sine. The key points I want to see are the same. I mean, they're in different places, but the zeros, the max, and the mins, wherever those are, that's the key points we want to see. Okay, here's where the fun argument / discussion / confusion begins. For sine, it was pretty easy. All the zeros were on the pi's. 0, pi, 2 pi, 3 pi, 4 pi. Got it. Where are all the zeros for cosine? Not at the multiples of pi, because that would be the same as sine, pi and 2 pi and 3 pi. Okay, we're getting there. What did you say, Felix? Every other multiple of half a pi. I think that's right. Is there a better way to say that? Like, that's correct.
I don't know.
Is there a better way? Anybody say that a better way? Every other multiple of half a pi? That's correct. You can say it a little bit better. I'm going to say the odd multiples of pi over 2. So that's pretty good. I mean, you were right. And someone over there was saying pi over 2, something about pi over 2. Be careful, it's not all the pi over 2s, because pi is a multiple of pi over 2. Right? I mean, it doesn't look like it, but it's 2 pi over 2. And 2 pi is 4 pi over 2. So it's not all the multiples of pi over 2, it's just the odd multiples, or every other multiple of pi over 2. And then cosine starts at 1. But other than that, they look the same, right? Like they have a different starting point. It's like they've just been shifted left or right a little bit. Like they have the same shape. In fact, if you didn't have the y-axis on there and you couldn't tell where you were, if you shifted one way or the other, you could make a match. And so, lots of similarities, but we do need to be careful because they're not the same. Probably the most helpful when graphing them to tell them apart is remembering that sine starts at 0 and cosine starts at 1. If you could remember that much, then you know it starts over after 2 pi, and you can fill in whatever you need to in between there. But the big deal is get them started at the right spot, and then you'll probably be okay. I need to check with Miss Morris on that one. Probably. By the time we get there, you'll be fine. You'll be fine. Part of that, the question was, is the test going to be open? No. The reason you'll be fine is, after we add tangent to this, it's just more practice on graphing. So Friday is given a graph, write the equation. So it's kind of just going backwards of the same thing. Reciprocal graphs, that sounds hard, but it's really not. Like graphs of secant and cosecant are just more practice with sine and cosine. That'll make more sense when we get there. Every day a review. Tomorrow's a review of what we're doing today. So, yeah, it's not easy, but that's kind of all we're doing this unit. Let me give you the worksheet for today, and we'll do a few things together on it. The period is how long does it take to show one cycle? So that's 2 pi. The length of one cycle is 2 pi for sine. And for cosine. Try to be misleading, but you're not being fooled today. So the length of one cycle is 2 pi. The domain, that word means the same thing that it's always means. That's the x values that it covers. So look at the graph of sine. Now we graphed it initially from 0 to 2 pi, and then 0 to 4 pi, and then we backed up to negative pi. But, especially if you think about the unit circle, you can spin around forever in either direction you want to. So what does that suggest the domain for sine is? Negative infinity to positive infinity. Or if you want to write the fancy looking R for all real numbers, you can do that. Cosine, what's the answer for cosine? Remember, we started 0 to 2 pi, then we went 0 to 4 pi, and then we backed it up. But it can go forever in either direction. So same domain. Range is the y values. So what's the bottom to top? -1 to 1, but with brackets. Good call. Because we want to include -1 and 1. Nobody caught that in first period, so maybe that's why the recording didn't work. It knew I messed that up and didn't want me to post that. Symmetry, odd, or even? Any idea what that means? Okay. Which one is this?
Does it have to do with the cycle?
It does. It does. Symmetry, odd symmetry is symmetry with the origin. Even symmetry is symmetry with the y-axis. So let's look at sine first. Origin symmetry means you can rotate it 180 degrees and it'll look the same. So you don't rotate yours, but I will rotate mine, and then you tell me if our graphs look the same. Right? I mean, I would have to keep going, or you'd have to keep going, or whatever, but it's the same picture if I rotated this 180 degrees. So that means that sine has odd symmetry. Right? Cosine. We'll do the same test. Hold yours the same, and then I'll rotate mine 180. Maybe I will. Do our graphs look the same? Yeah, some of you are like, wait a minute, that does not look the same, because mine's at a -1. I mean, ignore the labels there. Mine's starting at the bottom, and yours should be at the top. So that is not rotational symmetry. The other option was y-axis symmetry. That means if I fold it on the y-axis, will it copy onto itself? Yeah, I mean, if I extended it far enough back, I could fold it over and those two branches would copy onto each other. And so yes, it has even symmetry. Zeros, we already answered this question. Multiples of pi for sine. For cosine, maybe there's an even easier way to say this, but odd multiples of pi over 2. Asymptotes. Well, neither of those graphs have asymptotes, but that does suggest that maybe something is in our future might have asymptotes. All right, next let's play a little matching game here. So of the 6 graphs down at the bottom, which one is sine? A, B, C, D, E, or F? It's definitely B. How did you know it was B? Starts at 0. So we can label sine with B, or maybe it might even be better if we labeled B as sine of x, either one. And it's not labeled with pi's, with numbers, but we know that pi is about 3 and 2 pi is about 6, so that makes sense. And then which one is cosine? D. So I'll do I'll label cosine as d, and then I'll label d as cosine, kind of a double match there. And by the end of this week, or early next week, this page will be a great study guide, study reference to compare and contrast the 6 different graphs. Again, right now we just have 2, but baby steps. All right, flip it over. Let's do some of today's assignment together. Worksheet 1. Yeah. +2. You're already looking at number 1. Good. Think back to parent function stuff. So forget about cosine. If there's a +2 at the end of the graph, what does that do to the graph? Vertical shift of 2. So the rules that you already know still apply. Or at least the rules that I hope you already know still apply. So that +2 is going to take our regular cosine graph and bump it up 2. Now, you can do this, you can graph without doing what I'm about to do, but I think it's helpful to put that sort of midline on the graph. Because now that's kind of our new normal. We're going to operate off of 2. Okay, cosine. Cosine started at, what did cosine start at? 1, but we meant up 1. Now we're starting up 1 from our new starting point, so we'll be at 3 to start with. What do we say the period for cosine is? 2 pi. I'm going to put 2 pi on the graph. It's only one more grid mark out there. And if we start at 3, then we should end at 3, because that's what it means to complete the cycle. So those are maxes. Halfway in between at pi, what do we think is going on? A minimum, a maximum, or a 0? At pi. And you can look back at your other graph if you need to. So you don't have to look at the labels, but halfway between the starting and ending, we're at a minimum. So when we're at pi, we'll be at a minimum, which is down 1. Although down 1 from our new midline. And halfway in between there, we're at the zeros. Now, again, do not graph a V, right? I'm going to give you a pass on putting in the 0.7s as long as you can. I just about did it. The right-hand side was a little better than the left-hand side. Now let's back up and do 1 period on the other side. So we'll go back to negative 2 pi. So at negative 2 pi, we'll be at a maximum again. Halfway between the maximums, we'll be at a minimum. Minimum meaning negative 1, usually, but we've been moved up to. And then halfway between those, we're at 0. Let's see if I can do a better job on this one. That's better. Much better. So I've got the graph of cosine shifted up 2. So all those parent function rules that you memorized, and not really memorized, you just learned them in Algebra 2, and we've used them a little bit in here, we're still using those. 2, 3, and 4 is the same rule, right? Up 1, down 2. Let's skip to number 8. Because I want to do one more with sine, and because I want to do with a fraction. So look at number 8. All right, parent function experts. What did a number out front do to the graph? Do you remember? Like a multiplier out front. somebody said it, I think. The vertical stretch, or in this case, vertical compression. Use the fancy term squish. Compression would be a better option there, but a vertical squish. Just like sometimes it's helpful to sketch the parent function before you graph the change, sometimes it's helpful to graph the parent function before you graph the new one. So I know what sine looks like. Now I just need to squish that by a half. So squishing 0, 0 doesn't change anything. Again, we get out to 2 pi, it starts over. Halfway between the 2 pi, halfway between the zeros, or the endpoints, we're at another 0. At pi over 2, we should be at a max. Our max is usually at 1, but this one will be just at a half. Same thing with a min, usually at -1, but now we're at -1/2. So we get this squished sine wave. And if we want to extend it backwards, we can. It'll just be squished as well on the other side. Again, go to -2 pi. That's where it starts over. And then some people are really good at copying it over because they're just like visual. They can see that they just mentally copy it over. Others have to go a little more point by point. Halfway in between, we're at 0. Right here we'd be at a max. Here we'd be at a min. So there's 1/2 sine of x. All right, your assignment today is this worksheet, just 1 through 8. So the only transformations we're doing today are shifting it up and down and stretching it up and down. You know what 9 through 12 does. That shifts it left and right. But that's a little bit trickier to do with pi's and 2 pi over 3's and that sort of stuff. So try 1 through 8. Again, you're just shifting it up and down or stretching it up and down. And we'll worry about the others tomorrow.